Okay, hello students. Here is the new lesson, that lesson number 11, unit 4, algebra 2. The learning target for today's lesson is, what are we going to learn with the end of this task is, I can use known, here it is, I can use known values of logarithms to estimate the value of other logarithms. So knowing the known values of log, we can figure out the other one, and also we can use technology to determine the value of logarithm. We can use the Desmos.com or the yellow calculator TI-84 and Spire. So there are a lot of different calculators, but the one that you are going to use in the class is there TI and Spire. Sorry, the TI-84. So the first student's task is, let me go straight away here. Here it is. So you're supposed to figure out what is the value of log 10. So the first one, okay. So here it is, the first one. The first one is log base. Now see, there's no the g that you see. There is no base here. What does that mean is, whenever there is no base shown, it means it is 10. So I want you to write in the log at the bottom that 10, and then you have the black number, the black the black 10. So there's a 10 here. So it is log base 4 equals, and we don't know. Let's see, you don't know what is this. I'll put a box question mark. What is this? The blue color. Now, from last lesson, you see I always use red color for the base. Then the blue is the exponent, and in the parentheses, we put the. So first step is, what does this log we write in the exponential form means? It means you write the base as the first. So it is 10 raised to the blue color. What goes here? Okay, and the answer is the 10. So for what value of what do we replace in the box to get the answer as 10? And you can see this is only possible. 10 raised to 1 is 10. So the answer is this 1. So it has to be 1. So the first answer is 1, and this is all the explanation to show why it is 1. So that's how you figure out. And one more thing you have to notice is that it's like you get a formula type of a thing where you have a log base b, and if this is b, and the answer is always 1. So whenever you see the two numbers same, if it is log and it is like a b and a b, then the answer is always 1. So I hope that helps. Okay, let me write the second question. Second question is, it says log, so log of, now the base is the 10, and this is 10,000, and this is 10,000, and we need to know what is this. So first of all, the red is, this one is the 10, and then we need to know what's going to be the blue answer. So if you don't know the blue answer, either you can put a box, or you can just say, okay, let's put it like a A. We don't know what is this A. So then first convert this into logarithmic form to the exponential form. To convert to the exponential form, write the base first, the red base, and then raise it. So this one you raise like this going up. So the blue color goes as an exponent. So like this. So it is 10 raised to A, and the answer is the 10,000. So how many tens do we multiply to get 10,000? And you can see the answer here. What should be A? So the A has to be 4. And why A has to be 4? Because 10 times 10 times 10 times 10 is 10,000. Okay, it means 10 raised to 4 is 10,000. So if you see this 10,000, that means that A has to be. So this is equal to 10 raised to 4, and that's why we can say this piece, this A that I was, the question is, what was that A, right? This is the question mark. So what was that? And now we see it is 4. So your A has to be equals to 4. So the answer is this is 4. So all this explanation is required to really understand how where did this answer 4 come from? Some of you may use your common sense. Oh, is it not rebello? Just count how many zeros are there. Yes. So in this case, it may be 1, 2, 3, 4 zeros. That's why it is 4 because you multiply 10 itself 4 times to get 10,000. So the answer is 4. But not always it's going to be that zeros because sometimes we have a different log. It can have a log base 3. So that does not work like that. Okay, so hope that helps. Let me go to the third one. It looks little confusing because there's a decimal point. Let's write down the actually what's going on here. It is logarithm and the base is now remember 0.1. This 0.1, I'm going to write this as 1 over 10. See, I can write it as 1 over 10. And why I'm writing this, let's see. So this is the red is the base 10. And the answer is the blue color. We don't know what is the answer. So because I don't know what is the answer, I'll just put it like a A. I don't know what is this, okay? Now change it to convert this into exponential form. And how do we write exponential form is put the base, then raise to the power. So this 10 pushes this A up. So this one you push. Uh, so it goes as the exponent. That means that's the A part here. And then equals 110. Okay? Now this 1 over 10, I can write it as 1 over 10 raised to 1, which is in the properties of exponents as negative exponent property. This is 10 raised to minus 1. See? So all that we get is from this step to this step, both have the same basis. They have the same basis. So if they have the same basis, that means the exponent has to be same. So the blue A has to be, this blue A has to be this minus 1. So these two pieces are same because they both have the same basis. So A is minus 1 and you are done. So the answer for this is second, this one 0.1 is negative 1. So there is a trick also is when you have a, when you look at this piece, see this piece. If you look at this also, last time we seen log base 10 of 10. So last time we saw log base 10 of 10 is 1. Okay, this was 1. But this time it's a fraction 1 over 10. Look at this. This is 1 over 10. So if it is 1 over 10, the answer is minus 1. In place of plus 1, the answer is minus 1. I hope this helps. Let's do the fourth question. So this one looks difficult. Watch this. This looks log. What does this basically means? It is logarithm base 10 here, okay, of 1 over 1000. And the answer is what? Question mark, right? So we don't know this. So because I don't know this, I'll put it like, okay, you don't know, you put it like A. A is like, we don't know the answer. And the base here is 10. So all you do is change from logarithmic form to the exponential form. So it becomes 10 raised to the blue A equals the 1 over 1000. So this is 1000. And you can see the only way is that's possible is this is, uh, sorry, it is 1 over 1000. So it means 1 over 1000 basically is 0.001, which actually means it is 10 raised to minus 3. But if you get confused, just wanted to write one more step here. See, when you write 1 over 1000, it means it is 1 over 10 raised to 3. And when you want to change this to using negative exponent property, this is minus 3. See? And that's what. So we are getting confused because of this basic fundamentals that we forget. So this is minus 3. And you can see both bases. So when the bases are the same, the exponent has to be equal. So A equals minus 3. So this is minus 3. Okay. So the answer here is minus 3. So I put a question mark. What is this? It is minus 3. So, and you can see by common sense also it is 1 over 1000, right? So there were three zeros, 1, 2, 3. Uh, because it was fraction, it's just writing minus 3. That's it. So, but then the steps are very important there. Okay. Question number 11 point is like it's like a game, but what it does is there are a lot of cards there, and each of the cards we'll try to figure out, and then you can put them in order from increasing the smallest to the large number. So I'll begin directly with the first card, that is here it is. Okay, so here it is. The log. That's the first one. Okay, so the first one is, let's see, we can easily know we already know the answer for this, but still I'm putting some colors. Like, look at this. This is the red 2. I'll put this red. This is important for me, base 2. So that's the base 2 of 64. So this is 64, and we don't know the answer. I'll put a blue color here. So let's say blue color is A. And then when you write in the exponential form, the base is the first, so it is 2 raised to, the blue is the A here, and the answer is 64. So we need to know how many times do we multiply 2. So it's like 1. So how many twos do you multiply? 1, 2. If you multiply 2, you get 4. Then if you multiply another 2, you get 8, right? You multiply another 2, you see you get 16. You multiply another 2. So how many of these 2's do we multiply all the way to get to this part? So these are 32 times 2 is 64, see? And you have a 64 there. So how many 2's did I use? 1, 2, 3, 4, 5, and 6. So the answer is 6. So this piece, whatever that is, it is 2 raised to the blue A equals 64, but 64 itself is the 2 raised to 6. See? So we've seen that there are 6 of these 2's that multiply to get 64. And that's why common sense, they both have the same bases. So bases are the same. These two both left right has the same base, so the exponent has to be same. So this exponent has to be, say, a equals 6. So I hope you we did this, but just kind of reinforcing what you already knew is, so log base 2 of 64 is, answer is 6. Okay. Then what about the next one? We can do, now that we can avoid some of the step because we already know this. So this is this part. So because we don't know, I'll just say, hey, what's this answer A? Then you use the base and push this A up. So you go in the clockwise, counterclockwise direction, and you say, okay, the base is the 2, then raised to A equals 8. So an 8 means it is 2 times 2 times 2 times 3 of them. See? So this we already know. So if this base is the same, so the exponent A has to be 3. And you're done. So that's all it is. So the question is, why is the answer 3? And you can see these are direct questions where all of you should know. So this is 3, and this is 4. Now we'll do the 4 first. Okay. Now this means it is log base. So this is log. So the base is the 5. So this is the 5 here. So that means I don't know what is the answer, and because we don't know the answer, I'll put it A. Okay. Now we'll use the switch to the exponential form. So 5 raised to the exponent A, and the answer is the black number 125. See, so it means how many times do we multiply 555? You can see how many 5s do we multiply? 1. 5 times 5 is 25. This is 25. But if you multiply another 5, this is 125. See? So it is 1, 2, 5. That means 5 raised to 3 is 1, 2, 5. So all we do is this is 5 raised to a, and 125 is 5 raised to 3. So both have the same base. So you cross it. You can even do this way to show when the bases are the same, the exponent are the same. Okay. So this is how it does. So once you get a hang of it, you can also do directly. What's the next one? It's almost like the same thing except there's a fraction. So there's a 1 over. So like this, see? So this looks a little, this doesn't look good. So what I will do is, instead of this piece, let me write it nicely. Log, it's like this. Log base as the 5. Okay. See how, and then write 1 over 1, 2, 5. Okay. And because we don't know what is the answer, let's call it a blue color A. Okay. And then change it to the exponential form. So start with the base 5 raised to the blue color A equals, and 1 over 125, the black one, 1 over 125. Okay. Now remember, we just now have seen this 1 over this piece. See this part? 125 is 5 cubed. So let's write that. So this is 5 raised to a equals 1 over 5 raised to 3. But then we can get away with the fraction using the property of negative exponent. So the plus 3 changes to minus 3. See how beautiful this is? So 5 raised to a equals 5 raised to minus 3, and both have the same basis, so a becomes minus 3. Now another thing is take away from here is the answer for this we got, the answer for the right side, the answer was plus 3, and the answer that we got now is minus 3. What does this mean is, if there is no fraction, it is plus 3, but if there is a fraction, look at this is 1 over 125. So that answer is minus 3. So this is a good takeaway from these two examples. How do you know it's going to be negative, correct? So if there is no fraction, it is positive. I hope I'm making sense. Let's group to the next two. So if you see the first one, it is like this. So it is log base 10. We already did this actually, but you forgot. So remember the trick is, if this 10, then if this is 10, if these two pieces are the same, the answer is always 1 straight. You don't even have to think like this, because we already seen that logarithm base b, and if this also is b, the answer has to be 1. So this is straight away 1. But if you see the second one, this one is same as log base 2 of 1 over 8. Just imagine the very first one that we have seen was this. The first problem that we had was log base 2 of, I think it was 8 something, and we got the answer is 3. Check your answers. This was plus 3. Now this one is 1 over 8. So if it is 1 over 8, it changes to minus 3. That's it, you're done. So when fraction is there, it's going to be negative. Got it? So without a fraction, you will see it is 3. That we already did. This piece we already did. I think the top part is because 2 raised to 3 is 8. That's why. See, 2 raised to 3 is 8. So the question is, why did you say 3? Because 2 raised to 3 is 8. And the other one, there's a fraction, and we can always prove. So by now, we should be using our common sense and say, okay, if there is no fraction, then you just write positive. If there is a fraction, write minus. That's it. So I forgot to keep the track of one number. I think this is for 7, I think, right? 7, 8, hopefully 7, 8. Now, if you see the left side, it's all about the base is the 10. See, this base is 10. So the question is, what is this, right? You can say I was writing A, and you know that 10, the base raised. So you push this up, it goes up. And when are you going to get this 1000? And the only way is it has to 10 raised to 3. That's why we can write cross this out and you get a equals 3. Now, in this case, the one that you see on the right side, log, it's 1 over 5. Remember, if there was no fraction, if it was just this is going to be 1. Look at this. So this part, whenever the base is the same as the whatever in the parenthesis, the answer is 1. But uh, this one you have it's like this. It's a fraction. So even the number it looks the same. This is 5. Okay, this is 5, and this is 1 over 5. It's a fraction. So what do you think is the answer here? So if this is plus 1, that becomes minus 1. That's it. So just change the sign there. Okay. So that case, so this one, so we do know this piece, this we know this piece. So because whenever the base is the same as this input, then the answer is plus 1. But this one, there is a fraction, and it's going to be minus 1. And the reason is 1/5. Remember, 5 raised to what is 1/5? That's what it is. And the only way this is possible is it has to be minus 1 to write it as 1 over 5 like this. Okay. Okay. Hope I made sense to you. Let's see uh, the base you see here is it is log of this 10. I'll put it right down to see the difference. And this is the 10 raised to minus 3. And says, imagine we don't know the answer. I'm just saying, imagine you don't know and just put a put a blue color A like this. So by changing from log to the exponential form, you start with the base, which is the 10. Then you raise this to A. A goes up, so this is up. And the parentheses stay by, so whatever is here, you write on the right side. And you can see you already got the answer there, right there. They both have the same base, the bases. So these bases are same. So if the bases are same, then the exponent has to be equal and you're done. That's it, you're done. So what is the takeaway from here is like a formula. And we can create and this works for anything. It's like this. So logarithm, and if there is a b, and if it is b raised to, let's say, n, the answer is directly n. That's it. So it doesn't, as long as the base is the same as whatever the base of the exponent, see this power there, b raised to this has to be same. Now, if the n is 1, then it is 1. But if it is anything else, then it is going to be whatever this piece n, this n is right here. So sometimes they also use kind of, you can also think of like this. Suppose you have log of 7, and if the 7 raised to minus 5, so all you do is you just write the 7 and uh, exponent minus 5, whatever this exponent, that's the answer, and you're done. So not much. If you see on the right side, we know log 10 base 10 of 10 is 1. But now they have a fraction. So if there is a fraction, you just put a minus 1. That's it. So simple. Okay. So this is because the base is 10. 10 raised to minus 1 is 1 over 10. Okay. And that's why we can write this as 10. We can directly say it's minus 1. Okay. So that's the answer. Let's move now. See, guys, are you getting it now? What I'm doing? So it's like the same thing but different situation. Practice is the best teacher. Let's really get that piece. Okay. What about, can we do this in seconds? Alessandro. First one, log base 5 of 1. So what is the answer? Remember the formula? It's like a formula whenever you have Whenever you have log base b, and if it is 1, answer is always 0. So 1 means this answer is 0. The question is why? It's because 5 raised to 0 is 1. See, when this base is pushed this 0 up, so I don't like the way they show this. This 5, they should have written log like this. So this is looks better like this. So look at this black 5 there. So 5 raised to 0 is 1. See on the right side, this is log 2, right? So just imagine we don't know. I'll put a question A there because we don't know. Let's put it like a blue color A. And this is the base. This is the main base. So start with the base, push this A up, and the answer is 0.25. See? But what is 0.25 means to you? So it is 2 raised to A. So So 2 raised to A is actually at the most I can write this as 25 divided by 100. Look at this. Okay. And 25 divides 100 as 1/4. Can you see this? And 1/4 basically means 1 over 2 square. And this basically means in the negative exponent property, it is 2 raised to minus 2. So if you try to compare this this piece to this piece, both have the same basis. If they have the same basis, then the a has to be, the exponents are same. So a has to be minus 2. We are done. So sometimes little tricky like this, and I hope I made sense there. So this was little tricky there, but made sense. Is that okay? Look at this. The first one is there's a 1. Log of 1 is always 0. So without thinking now, you should be saying, hey, there's 1 there. So it has to be 0. So some of you will still will be wondering why. Because when you start with the base, which is the 10, and you raise this up, the only way this answer is going to be the 1, it has to be 0. That's the only way. And that's why. Look at the next one. It will So this piece, there's a log and there's a 5 here, right? And let's imagine I don't know this answer. So what I'll write is, I'll put it like a, you can put A. Let's put it like a A. So let's put it like A. And then you convert this to the exponential form. So the 5 is the main number. And then you raise the blue one, and then this equals 0 black one, see 0.04. Now what is this actually? You can see this, it is, if you multiply 100 and divide by 100, so it's like 4 over 100, and 4 divides 100 as 1 over 25, and 1 over 25 is 1 over 5 square. So what did we get is 5 raised to a is 5 raised to minus 2 in the exponential form. This can be written as 5 raised to minus 2. So look at this beautiful form. So they have the same basis. If the base, same base, if the base is the same, the exponents become equal. And because of the r equals, so the a is minus 3 and you're done. So little tricky there, right? Because the 0.04 has to be first convert into a fraction, okay? 4 over 100, which is 1 over 25. 25 is 5 square, and that's how you get the answer. Okay, so this problem, question number here, this one, this base is, so if I put a log, it is 2, and log base 2 of this is, imagine we don't know the answer. Okay, so this means, what is this a? Let's put it like a, and then we can write this in the the exponential form, you take the base, raise it to the blue, and the answer is 10. Now, if you see this answer, we need to know here. Now we don't do know 10 raised to 0 is 1. Sorry, 2 raised to 0. 2 raised to 1 is 2, and 2 raised to 2 is 4, and 2 raised to 3 is 8, and 2 raised to 4 is 16. So the number 10 is between, so this piece that we have, so this 10 that we see is between here. So you can see the 10 is between, so the 10 is between this 8 and 16. And this 8 is 2 raised to 3. This is 2 raised to 4. That means this 10 has to be 2 raised to something. So whatever that question mark has to be between 3 and 4. See this? 3 has to be that box, whatever that is, the value of this. So this is less than 4. So that means this value is between. So the value is between two whole numbers, between two whole numbers. Which one? 3 and 4. And you're done. So that's all. So you approximate. So you can see also 10 is more closer to 8. Okay. So because 10 is more closer to 8, the value of 8, the value of this A will be more closer to 3. So it could be, so because 16 is way away from 10, more closer to 2. So you can see 3.2, maybe 3.1, I don't know. We can always use the calculator to figure out. So this will be around somewhere there. Let's go to the next one. Okay, so now this time we have log. Uh, so log base, again they use the same base, and you can see 20. Now the 20 which you have here is between 2 raised to between 16 and I'm using 32. Now, why did I pick this 16 and 30? Because 4, when you multiply 2 itself 4 times, you get 16. And if you multiply 5 times, you get 32. So this 20, the piece is, it has to be 2 raised to some exponent. And this exponent has to be between 4 and 5. So we write this answer is the value. So this is value or exponent which is when raised to 2, you're getting then it means the value has to be between two whole numbers 4 and 5, and you're done. Okay, this time this both has got base as the base is the 5. This is the 5. Here also, let's see, this is 5 of 10 and 30. So we can easily use our ideas. That means 5 raised to 1 is 5 and 5 raised to 2 is 25. See? So this 10 is between 5 and 4. In this case, 5 raised to 2 is 25 and 5 raised to 3 is 125. And this 30 is between here. See this part 30? So this has to be is 5 raised to an answer between this 2 and this 3. Likewise, this is 5 raised to 1. This is 5 raised to 1 is 5. 5 raised to 2. And the 10 that you see, this 10 is right here, which is 10. So it has to be between, so whatever that you are raised to has to be between 1 and 2. So this answer is the value between 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 this one and this two. So 1 and 2. But this value, this is value, this is the value between 2 and 3. So because of this 2 and 3. So as we do more and more of this, you get an idea exactly how to. Okay, watch this. This one is 10. The base is the 10. So let's start. 10 raised to 0 is 1. 10 raised to 1 is 10, and 10 raised to 2 is 100. And you can clearly see this. This 20 is between here. This is 20. So it has to be 10 raised to 10 raised to exponent that is between 1 and 2. So that means the value, this is the value between 1 and 2. Okay. So this one, look at this. This means the 2 is used. So 2 raised to 0 is 1. 2 raised to 1 is 2. 2 raised to 2 is 4. But there is a fraction. So if I write 2 raised to minus 1, it is half. 2 raised to minus 2 is 1 over 4. And 2 raised to minus 3 is 1 over 8. Okay, so this piece is a logarithm of base 2 of 1/5. Okay, now there is a fraction. So we'll start with 2 raised to 0. So 2 raised to 0 is 1. 2 raised to minus 1 is 1 over 2. 2 raised to minus 2 is 1 over 2 square, which is 4. And 2 raised to minus 3 is 1 over 8. So if you compare here, where is this 1/5? So 1/5 will be between, see this part, so between these two, 1/4. So 1/5 that you see is between 1/8, 1/8 and 1/4. If you see the 4 is less than 5 is less than 8, this is when it is this form. But if you flip it, then it takes this shape, and you can clearly see this one, this. So that means we need to know what is this 2 raised to what, right? Now this is the 1/8 is 2 raised to minus 3, and the other one is 2 raised to minus 2. So that means the value has to be, the answer has, this piece has to be between minus 3 and minus 2. So here you write the value between, so you don't say between minus 2 and minus 3, but you say between minus 3 and minus 2. Okay, and you can clearly see it does help you. So by just looking at it, you know that only thing you have to write 1 over 8 first and then 4, and not this. This is if it is without, if it is just a regular integers. When it is fraction, you have to be very careful. In this logarithm, and you can see there's a 9,000 and there's a 10, and 10 raised to 2 is 100, and 10 raised to 3 is 1,000, and 10 raised to 4 is 10,000. And this 9,000 is between 1,000 and 10,000. So this should be 10 raised to some number here, which is between 3 and 4. So this answer is between 3 and 4. And that's it. So and 9,000 is more closer. So if I put a 9,000 here, that's closer to here. So this will be, the actual answer will be almost closer to 4 here. It's almost maybe 3.6 or 7, 8, 9. Now if you see the next number here, there's a 5. Now the base used here is 1 over 20, right? Now you know 20. Okay, so now let's see if I want to find out this question. Okay, so what is log base 5 of 1 over 20? And imagine if you don't know the answer, I'll put it like a. We can change it to the exponential form and say, okay, the base is 5. So it is 5 raised to a is 1 over 20. Now the main number that you see is the 20, right? Now, and this is the 5. Let's see what's happening with what is 10 raised to 0. 10 raised to 0 is 1. 10 raised to 1 is 5. Sorry, 5 raised to 1 is 1. 5 raised to 2 is 25. And 5 raised to 3 is 125. So the number 20, let's see the 20 over here. So 20 will be between 5 less than 20 less than 25. Okay, so it means we can write this as 1 over, taking the reciprocal of all three of them, you can 1 over 25 less than 1 over 20 and less than 1 over 5. So this means this is same as 1 over 5 square less than 1 over 20, and this is 1 over 5 raised to 1. And you can use the negative exponent property, and this is 1 over 10 is, so 1 over 20 is 5 raised to a, so this becomes 5 raised to a, and that is 1 over, sorry, this is 5 raised to minus 1. And you can clearly see here what you get is this piece, this piece, sorry, you can see the exponent. This is a, that's a minus 2, and this is minus 1. So the a has to be between minus 2 and minus 1. So the value of this is it's the value between minus 2 and minus 1. And that's it. So I hope I made sense to you. Now, here's an example. We need to know which one is bigger among the two. So what I'm going to do is let's call this as P, and let's call this as Q. Okay. By using the definition of logs, we can write 10 raised to P is 1 over 5. And here, this is the base is 10. So this 10 raised to Q is half. Okay. Now, we will use that 10 raised to minus 2 is 0, 1 over 100. 10 raised to minus 1 is 1 over 10. 10 raised to 0 is 1. 10 raised to 1 is 10. And 10 raised to 2 is 100. Let's see what if we have here is 1/5 and this is half. And you can clearly see this number is between these two pieces. Can you see this? So I will do only this piece just to make sense. Let's take only the first one. So, so in between there is a 1/5 here. Can you see that? So that 150 is 1/5 lies between 1 over 10 and between 1. So these are the one, this two pieces. So 1/5 is between. So when you have this 1 over 10 is same as 10 raised to minus 1. And this 1/5 is, because of this, is 10 raised to p. And this is 1, this one is 10 raised to 0. So now you have all the bases the same. That means the exponent has to carry the order of inequality. So this p, so it means minus 1 less than p and less than 0. It means the log, this log, that means this answer, log of base 10 of 1/5 has to be between minus 1 and 0. That's what it means because that's p. Now the same thing we can think of here also because half also is, so half also is here. Okay, half also is here. So we can also write this answer will be also going to be between with same similar steps like this. It will be log 10 of half between minus 1 and 0. But the question is which one is bigger and which one is smaller. Now look at this. 2 is less than 5. If I take the reciprocal, it is 1 over 5 is less than 1 over 2. And then if I take raise both by 10, so that means 10 raised to 1/5 is less than 10 raised to half. And you can clearly see that means this is Okay, I kind of made a mistake. Like this is 1/5 is, so this is the 1/5 is 10 raised to p. So this is 10 raised to p, and half is 10 raised to q. And from here you can see both bases are the same, so we can from here write p is less than q. So p is this piece and q is this piece. And I hope, even though it is not neat, and I hope you understood what I'm trying to say. But then there's another way to do also is, if you see the logarithmic function is inverse of the exponent. Suppose this is the graph for 10 raised to x, and how does the other graph is the log graph goes like this. So the log graph basically is an increasing function. Now, what is that increasing function means? If you have two inputs here, A and B, then log whatever that 5 of A is always less than log of B. So this is another way to show this, but we are not using this here. And same thing, if I have one, we do know 1/5 is less than 1/2. So that means log 1/5 is going to, no matter what base is, log of half. So the base, in this case, the base is 5. So I hope, sorry, the base is 10. And this helps. Okay, the next question is, this is lesson number 10, sorry, 11.3. Task is, so you're supposed to use the calculator, and this is already done in the class, so I don't think you need any assistant. So the equation, if this is equation is given, a student writes the equation in the logarithmic form, and you can see these two pieces are the same. One is in the exponential form. So if you are given in the uh, exponential form, you need to convert this into log form, because the base is the red color 10 here. See, this is the base is that. So if you have 10 raised to uh, m is 9, and what that means is we can use the log. Base is the 10 of 9. I'm sorry, it is 19. So it is 90 is the m. So on the calculator mode, if it depends on what kind of calculator you use. If you use TI-85, just make sure get a screen there, and there's a maths here. So click on the math, and then just scroll down, and you'll come across log of a base a. So it will show log base. So it means that you just have to you will see the blinking here, and just plug in this as 10, and you get 19. And depending, they're asking what might another student say log base 10 of 9 can be expressed in different ways, because different calculators give uh, place value depending on how many place values you have the log. Like in this case, they give you 1 point. So sometimes this value is the approximation for this value. So it depends on how many place value you want to truncate it to. So this number is truncated to 3 place decimal. So using the calculator, question number 1, 2, and 3 you can do directly from the calculator. So express the solution to each equation using logarithm, and next find the approximate value of the solution. Now they give you 10 raised to m equals 24. So change it to the log form. So it is logarithm. The base is the 10. So this will go right here. And the output here is 24. So this will become the input here. And that's the m. Now this is what you plug it in the calculator, and you can figure out by using the calculator. Same thing in this case. You write this in the form of log. The base is 10, and then the output is 750. So this becomes the input, and that's the n. And you plug this in, and you get the answer. Next is estimate the value of each expression. So you're given, let's see, what is this? Log. Same thing. If you have log of 90, one way is to get with calculator, you can figure out whatever the answer 1 point. Okay, and that's another way to calculate is uh, to estimate. So the question is, can you estimate what is the value of this? Now remember 10 raised to, let's put this, we don't know the answer, and we put it equal to the some variable p or a. So that means 10 raised to a is 90. So we know that 10 raised to 0 is 1, 10 raised to 1 is 10, 10 raised to 2 is 100. And this 90 is between, so this 90 is between here, somewhere here. So that means I can write 10 is less than 90 is less than 100. But 10 is 10 raised to 1, 100 is 10 raised to 2, and 90 we did write it as 90 is 10 raised to a. So this is 10 raised to a. So all three of them have the base is the 10. This is 10, this is 10, this is 10. So the exponent has to be equal. So the value of a, this a will be between, or the log, this log will be, which I took it like a. So a is the value between 1 and 2. So this is how you can estimate. And because 90 is more closer to 100, this is the value could be more closer to 2 because 90 is close to 100.